Some of you may ask, what are the weird creatures that just linger around humans just then? The name of the creature is the Mexican wolf, or known as lobo. It is the smallest subspecies of grey wolf in North America. So here you can see the Mexican wolf is large, is around the large dog size, and most of the fur is grey. So we decided to research the growth of Mexican wolf in New Mexico and Arizona. So Lutfi, why we decided to research on this topic?
Okay, so the reason why this topic is chosen because of the Mexican wolf is endangered species, where the native species is the white being marked as an endangered and subspecies. Although this genetic is represent a modern conservation effort, which is a unique animal since distinct from just surveillance and to prevent the extinction. Also, this predatory instinct, Mexican wolf prey on herbivore, which is to stop the animal from eating too many plants and allow the forest to grow back healthy and keep the water clean.
So here is the table of data of Mexican wolf population. To begin with, I would like to analyze the population of our research animal by the range of 20 years in certain areas. The table shows the Mexican wolf population in Arizona and New Mexico in the year of 2005 until 2025. According to the table, the animal experienced early instability but has been consistently growing since 2011, which shows the value of 67 population. Next, it also reached its highest level ever recorded by 2025, which has 319 population. But in the early years from 2005 to 2010, the population of this animal in the year 2005 had 52 populations, but it started to drop during these years from 59, which in the year of 2006, to 42 in the year of 2009. This suggests instability in the early recovery program. To conclude, after 2010, the population never reduces again, and instead shows year-to-year growth due to certain factors like human intervention.
Going back to Honolulu just to get that Maui Wowie, that Maui Wowie.
So, for step 2, in order to get the particular solution, first of all, we need to generate a relationship between the change in population over time that is directly proportional to the population of number of Mexican wolf at time t, which is year. Then, we use separable variable method by separate different variable into each side. Then we integrate both sides and it gets us P equal to plus minus EC times EKT. Then the next step we need to do is let plus minus EC equal to A, which represent the constant. Then we use initial condition at year 2016, which is P equal to 0 and P population is 140. Then we insert the value back into our equation and we get our general solution, which is P equal to 114 E to the power of KT. Then we need to solve for our particular solution by using different value of T and P. We use T equal to 1 at year 2017 and population is 117. By substitute the value into the general solution, we get our constant K, which is 0.0259, and substituting that value of K into the general solution, we get our particular solution, and the final equation is Pt equal to 114 E to the power of 0.0259t. Okay, now we're going to the other side from the step 2, so we're going to the step 3. So we need to find the future value from the equation that we are just already state from the step 2. So the equation that I want to use is T in bracket T equal to 140 exponential 0.0259 T. Okay, so I use the future value from the current, which is the 2027, where it corresponds to T equal to 11. So I substitute the T11 equal to the equation, and then I got 141.643, and we approximate the whole number, which is 152. Okay. Where this is predict Mexican wolf population for 2027 is 152.
Now, after we predict the future value, we can predict the past value. So, the initial value we use is at 2016. So, we can predict below 2016. So, for example, we predict the 2015 value. So, the T at 2015 is -1. We insert the -1 at the particular solution. And after that, after some calculation, we can approximate the value. So the value we get is 111 Mexican wolf at 2050. So
Now it's come to my part, and I will explain to you about the dataset graph. This graph shows the Mexican wolf population from 2005 and until 2025. In the early years, the population fluctuated between the numbers 40 and 60. Around 2011, growth became more noticeable, and after 2016, the population increased steadily each year. By 2035, the population reached its highest point, showing the strong long-term growth. And overall, the graph highlights a shift from instability to consistent recovery, reflecting how the species has rebounded over time.
So here's the graph of the particular solution. We also plotted the graph of PT, which is the estimated population versus time. This graph shows an exponential growth model. This indicates that the population increases at a rate proportional to its current time. So let's zoom in a bit. So here we can see that the graph does not touch the x-axis because the x-axis is the asymptote. This instead, the slope of the curve becomes steeper as time increases, which means it is increasing faster over time and also consistent with population experiencing position growth rate. Other than that, the model predicted because the curve continues rising beyond the provided data point, the model can be used to estimate future population growth assuming conditions remain similar.
okay, now after we did all that, we can analyze the graph. And the first question that some people may ask, are the values calculated from the particular solution consistent with the actual value? So after some research, me and my team, the answer is no, it is inconsistent. This is because while both graphs show an upward trend, they are inconsistent because the graph of particular solution has smooth curve, while the graph of data set have up and down. So furthermore, the particular solution didn't account for outside factor, such as the breeding pair of wolf and the illegal killing and the enforcement of law. So moreover, the actual Mexican wolf population grew rapidly than the model predicted. So that's all for me.
Alright then, so we are going to the question 2 from the step 6. So for this question, we asked to determine whether it have like a percentage error from the calculation that we just already stated. So for this one, we need to determine the percentage error by calculate the actual value minus particular solution in the bracket in the form which is doesn't have negative sign. So we divide it with the actual value, and then we multiply that with 100. So for this one, I determine from the past value and the future value, and then we got the
we estimate the percentage is 13.36, whereas it's quite heavy.
So, for question 3, if there are differences between the actual values and the calculated values from the particular solution, explain the possible reasons. So, firstly, the model assumes continuous exponential growth, but real population do not grow perfectly. Based on the equation, the population changes over time. So, the real population grows irregularly and unpredictable way because nature does not follow a perfect curve. For example, birth and death rate are vary year by year. Second, human involvement affects wolf populations. Mexican wolves are heavily managed by humans, so the population numbers are influenced by first, introduction or removal of wolves. Second, cultivation program. The cause, it creates sudden population jumps or drops that the equation cannot predict. So thirdly, environmental changes are not included in the equation. Factors like habitat loss and weather changes are thusly measurement errors in the real data. Real wildlife population counts are often estimated rather than the exact numbers because wolves are difficult to track and some wolves go uncounted.
Moving further, the question 4 asks about the factors that influence population growth or decay in the past. Well, from 2005 to 2006, the Mexican wolf population grew because the legal protection were introduced, hunting was reduced, and more breeding pairs formed. Between 2006 and 2009, the population declined due to the SOP 13 rule, which permanently removed wolf attacking livestock and poaching further reduced numbers. From 2009 to 2014, growth resumed as SOP 13 was stopped, crop survival improved, and conservation programs strengthened the recovery. However, in 2014 to 2015, the population declined again, mainly from high natural mortality and ecological pressure that outweighed human protection. And overall, this shift show how both human policies and also the natural factors shape the population trend.
So, now, for the last part, what factors do you think may affect population growth or decay in the future? From my point of view, one of the factors that may affect the Mexican wolf population growth is the continuous efforts and initiative from the governments and NGOs to support the preservation of Mexican wolf species. While on the other hand, its population might be affected in negative ways such as land exploration and development that harm their habitats. That's all.
To summarize, the Mexican wolf population is recovering, growing from 42 wolves in 2005 to a predicted 319 by 2025. Our map model shows a steady upward trend. However, real life is not a perfect curve. The actual numbers go up and down because of things like illegal hunting, weather, and habitat loss. While the numbers are improving, these wolves still need our protection and support to survive in the future.